Hello, my name is Ivan Cardenas. I am a PhD candidate at the ITC faculty in the University of Twente, and I'm currently working on digital planning and digital twins for supporting decision making in the planning process. So if you want to know a little bit more about me, you can visit my website. The link is on the bottom. But today I'm going to talk about how to create geoprocesses and dashboards. So in this presentation, I'm going to start showing you how to create your own geoprocesses using ArcGIS Model Builder. And then I'm going to show you a little bit of how to use Cesium for your 3D model. This could be an option that you could integrate in your digital twin. And at the end, I'm going to show you how to build dashboards, both with Python panel and also with ArcGIS dashboards. So let's start by the geoprocessing. So the model builder is this graphic interface where you can kind of like visually program what you want to achieve. So instead of hard coding, writing everything up, you can use these visual tools where you can integrate tools that you already know or you already have. So this allows you to create workflows that can be automated, and it will be easily adopted by your company or your your own work if you work independently. But the idea is that in this model builder, you can just easily just click, drag and drop items, connect one with another. You can create iterative processes for speeding up your workflow. And you can also show this full change of what you're trying to analyze, so people can also understand it better, and it will be easier for you to navigate and to understand where maybe some of the difficulties on your process are. At the end, you can run it directly on the model builder, but you can also run it as a separate tool. And at the end, the idea is that you can create your own set of tools and not be constrained by the ones that are by default on either ArcGIS or QGIS. So the idea is that you can create your own tools and integrate it much more bigger workflows for your process. So I'm going to show you directly how we are going to build this. Okay, so here I have a Sentinel-2 image, and I have separated like all the bands from that image, so from 1 to 12, and I have given names to each of these images, so it will be easier for me to manipulate. And what I want to do here is to extract the water bodies of this image. In this case, we're focusing on a city in Brazil, which is called Manaus. This is in the middle of the Amazon. And what I want to do is that these extraction of water can be easily done and updated with any new image that I come from. So you can go here to this tab that says Toolbox in the catalog, and my suggestion is that you start your own toolbox. So I'm just going to create a new toolbox. I'm just going to save it in the folder that I'm being working on, which is this tutorial, and I'm going to just call it my toolbox. So now what I can do is inside the toolbox create a new model, and it was gonna come with an empty screen. So in this place I can just go to the processing tab and start dragging and dropping tools. So I know that I'm gonna use the raster calculator as I'm gonna be using operational math with each of the bands. So I'm just gonna drag this raster calculator tool into the model screen, and as you can see, it will drop here. It's white because it hasn't been configured by anything. And I'm gonna add, I just want to use band 3, band 4, band 8, 11, and 12. And what I'm going to do is to double click on the raster calculator, and this will open the information of the tool. And I have searched around, and I found an expression that allowed us to detect easily water bodies. So this expression is 2 times the band 3 minus 1.4 minus 1.8 minus 1.11 minus 1.12. And I'm gonna save it. There's two options that you can do. You can do in memory. So I'm just gonna write memory slash the name of your file. So in this case, I'm just gonna say um, water bands. And now you can see that this tool turned into yellow, saying that the tool has been configured, and green for the output. So you can easily detect which are your inputs and which are your outputs. And what I can do here is also call this as an input parameter. So I'm just gonna right click on them and call all of these as parameter, parameter, and parameter. You can see a P shows up in the top of them. So now that I have these uh, water bands extracted, maybe there are some pixels that are a little bit contiguous to each other, and then I'm gonna have water bodies that are 1 or 2 pixels. So what I'm going to do is do a focal statistics and to reduce a little bit of that noise. So I'm just going to connect this output to my focal statistics as an input, and then I'm going to check the configuration. So in this case, I'm going to use a neighbor of 3 pixels by 3 pixels, and instead of using the mean type, I'm just going to use the majority statistics for this. I'm going to click OK, and my output, I'll double click on it, and I'll just call this again memory focal statistics. And now that I have created this, I need to classify what is water and what is not water. So I'm just going to use a reclassify tool, and then I'm going to again drag and drop. I'm going to connect this output into the reclassify. And here it's going to ask me like, okay, which type of field do you want to do? So I have done this analysis previously. So I'm going to start that the starting point is minus 50,000, which is the lowest value that I will get in this input. And starting from minus 4,500, I am starting to get values of water. So I'm going to say that node this is going to turn into no data, and then I'm going to say that from the 4,500 up to 1,000, which could be the maximum value, is going to be water. So I'm just going to put 1 as a new value, and then I can put all the no data as no data again, just in case I miss some value around. And again, if I miss something, I can change these missing values or something that I didn't put in my classifier as no data. And here I'm gonna save it again, memory slash water raster. So this will save it. All the things that we save in memory is gonna be saved as inside the RAM or in your computer temporary. Then it will get deleted. This will speed up some process, but you have to be conscious about how long are these processes taking of your space on your RAM, because if you're processing a lot of information, then it might get lost or it gets stopped. So okay, I have this water raster, and now I just need to convert it into a polygon. So I'm just gonna say raster to polygon. I'm gonna drag and drop my tool, connect them as an input, check the variables. So yes, I'm gonna take the input as from the value, and in this case I wanna save it as a final item inside my geo database. So in this case I'm using this tutorial, so default geo database, and I'm gonna save it as water polygon. Okay, in this case I'm getting a warning. Like when I was testing, I saved it with the same name, so it's gonna say, hey, there is a file over there, it's gonna get rewritten. So yeah, it's okay, and I'm gonna create select this multiport. Sorry, no, this is not necessary. And now I'm just gonna click OK. So I have my model set. As this is my final output, I can again set it as an output parameter. And let's say that for some reason this is a little bit not not really organized and you wanted to have it better, every time you can just click on the auto layout and it automatically will configure as in the sequence that you're doing. There's some things that you can do that, let's say you have another information you want to, for instance, use this split raster tool, and then you're going to connect it to the classifier, but you want to make sure that focal statistics applies first. You can just connect it here, from the result, and you can put it as a precondition. So that will make sure that these focal statistics will run before the next step. If you have a Python script or something that you want to include, that is also possible. I'm gonna show you. So you can go inside the same toolbox and right click, and you can make a new script. And let's say I'm gonna name this, I have a previous script which is for the wet bulb temperature. So let's say wet bulb temp, and I'm gonna label it as wet bulb temp. So you can see that I have in the name, it doesn't have space, which is how it's going to be stored. But in the label, you can put it like temperature, for instance. So this is what the user will show, or you will see. So you can go to the execution, and in the script file, you can open here, and you can import your Python script that you already have. So I have one here that I made for a previous project. So I'm gonna go directly to it. I have here my folder scripts, and this is the wet bulb temperature package. So you can see now that I have 3 parameters. The first one is the HR, which is relative humidity. Temp is the temperature of the environment, and then I have my output parameter. So it gets stored as here 1, 2. And what I'm going to do is that I'm gonna go here to the parameters. This is my previous field, so I'm just gonna show you a little bit how I did it. So label, which be the name that the user will see, so relative humidity, temperature, wet bulb temperature, and this is how the variables will get stored in the tool. And you can see that I put here the type double, so if you open it, there's a huge list of possible types of data. So this will make sure that you use the exactly type of data that you need for your tool. And if you have iterables, you can use multiple parameters, or you can use tables, depending on the tool that you have. By default, this will be into required, and the direction will be input. But for the second parameter, which is the output, you have to put here, instead of required, you have to do derived, and the direction will be output. So now that I finished the configuration, you're just gonna click OK, and here my tool gets created. So it runs initially to see if it's valid, if it works, and makes like a small test. If it runs, it will create it, and now you can drag it into your own model. So now you see white, and I cannot connect this here. You see, there is no option other than precondition. So what I can do is create a variable, and as my inputs were doubles, so double for the relative humidity, so I'm just gonna rename it relative humidity. I'm gonna copy, paste that same variable because I also need a double, and this one I'm just gonna rename it temperature. And I'm gonna connect these. Now you can connect them to the specific parameter that you have, and it will only show you to the specific type of your input that you need. So as these are doubles, I can connect them. And now you can see that it's the tool is still white, and this is because we don't have default values for this to run. So I'm gonna add some default values. Let's say that for the humidity it's 20. It's quite low, and the temperature it's 27 degrees, sorry. And now you can see that the tool is set it up. You can see here that the colors are different for the inputs, and this is because it has like this manual input and it's not connected to one of the items in the table of contents. And likewise, this output is not stored anywhere, it's just running on the fly. But for the sake of the exercise, I'm gonna leave it like that. and I'm gonna connect this as a precondition. So I want this part to run before the raster to polygon tool runs. I could run it right away here in the top, so I'm gonna just validate it, and oh yeah, everything worked. And I could run it here, but what I'm going to do is just save it. I'm gonna close it, and I'm gonna show you here that I changed the name to water and wet well. I'm just gonna double click on it, and you can see here the inputs. It seems I forgot to add the other ones as parameters, so I'm gonna go back, edit, and I'm just gonna add this parameter, and this will be a output parameter in case you want to later store it. Again, I'm gonna save it, close this, and when I open it, you see now it has all the bands that I need, and I can change the input not to be this band 3 but another one depending on what I want, or even search for another layer or another raster that I can use to calculate. So I'm just going to turn this off from my previous process, and I'm going to show you just the tool running. So I just click here and run, and I can open the details and see here what it's going on, how much time it takes for each of the steps. Might get some errors because of the processing. Here I got some warning, but you see now that it finished processing, and it make polygons for all the water elements. I'm just gonna change a little bit of the symbology so you can visualize it better. So I'm just gonna delete the edge and put a high blue on that one. So now you see these all the where the polygons were created, like even in small detail areas you can catch some of these polygons. So this tool that you created is now of your own, and you can have always these toolbox ready for you to set it up. If you want it to run kind of like in an external tool, not using after setting it up, not using ArcGIS, you can also go to edit, and you can export it here on the top. You can export it to a Python file. I'm just gonna save it as water and wet bulb. It's gonna save that I want to overwrite it because I already had this before, so I'm just gonna save it. And when I open it in my VS Code, I can see all the configuration and like the setups that are by default. So you can see the band 3, band 4, band 8, etc., and how the water polygon is stored in my database and my default database. But you can edit these items when you call the function, or when you want to connect it with other processes that you might be doing on Python. So this is a really good way of creating your own tools and having an initial visual setup, and then you can connect it to other sources. And that's it for now. So now let's talk about the 3D models and how you can incorporate them in Cesium. So Cesium is this platform that they can store photogrammetry, point clouds, whatever 3D object that you can think of, and they have this server where they store in these 3D models, and they optimize it to transform it into the 3D tiles. Now 3D tiles have become like the standard for hosting 3D elements into any platform. So Cesium is kind of like the leader that has taken this role of how to operate 3D information and into different platforms like Unity or Unreal, and even ArcGIS have their own SDK where you can incorporate Cesium into your programming. So I'm going to show you from a 3D object how you can incorporate it into Cesium, and how can you visualize them online. Here I have a set of buildings that are from the city of Manaus, and I just apply quick textures to them, and I have also some of the roads. So what I'm going to do is to export it from Blender to Cesium. So I'm just going to go to File, Export, and I'm going to choose this GLTF file, and I'm going to overwrite the file that I already have here. It's just gonna take some seconds. So now what I'm going to do is go to cesium.com. I already logged in with my account. You might need to create a new account. And what I'm going to do is go to my assets, add data, and I'm gonna add that file. So I'm gonna select my Manaus file, and I'm gonna say that this is a 3D model tile. So this will convert it from the GLTF to 3D tiles, and it's gonna take just some seconds to upload it. I'm just gonna close it here. And now that it has already uploaded, you can see that it doesn't have a location. This is because I was using on the fly 3D model. So what I'm going to do is just adjust the tile set, and I'm just gonna search here for Manaus, Brazil. This will just gonna take me a little bit closer to it, and I'm just gonna click on next. And by default, it tried to put some coordinates of the center of what you were searching, but I'm gonna correct that with in Blender by going to View. And here in the geo scene, you can activate this geo. This comes from the Blender GIS plugin. So you can see here the coordinates of your model, and I'm just gonna copy both coordinates, both latitude and longitude, latitude, and you might need also to adjust the height. So in this case, let me see. No, yeah, so it's floating a little bit. So what I'm going to do is try to get a little bit of the height using this geo coordinates. So I'm just gonna hover my mouse a little bit on the area. It's marking minus. Maybe it's reading the projected ones. So what I know that my location is around 23, if I'm not mistaken, a little bit less. Unfortunately, because the Blender is not really connected to the other ones, to the GIS models, these kind of adjustments are a little bit tricky. So I'm just gonna leave it like that. I'm gonna save the location, and I'm gonna go back to my assets. Now you can see that this preview window already adjusted it, and you can see here in the bottom that it has a JavaScript code where you can call your asset and anyone's asset if you have the code. So now I'm gonna just open the complete code so you can see how it's structured. And this is kind of like it's a sand castle where you can play around and put some code. So here you can see that it has like the access token, the general map, the asset that I'm calling, which is the Manaus building, and the default 3D Cesium tiles, which is kind of like the style that is loading, and some extras, which is this bar here where you can just create some animations. And you can even open it in a new window if you want, and this will render the same items and external and like large view of what you have just uploaded. So yeah, here are my windows, and you can see a little bit of the terrain. And the cool thing is that Cesium has all the world already pre-rendered, so the terrain of the world is already loaded up if you zoom in, and that eases up loading some buildings or some objects in 3D. My previous recording kind of froze, so I'm just gonna finish there. There was nothing much that I wanted to say about the Cesium platform, and now I'm gonna talk you about the dashboards. So the dashboards are the tool that where you can easily display information and that people can interact with it. The idea is that it could be super easy to understand, and then you can like maybe move one item or the other one that you want to show quite easy. And I'm gonna show you how to build these two types of dashboards, one with Esri and ArcGIS Online, and the other one with Python and Panel. So I'm back in my ArcGIS Pro, and I downloaded some information about the stores in Manaus, and I just put some symbology to a little few of them. There were so many that it was like, yeah, too much to decorate right now. So once you have, let's say, your map ready, you can go just to share, and you can create a web map from your data. So all the layers that you have here and the base maps will be configured as a new web map. You just click on there, and then this panel will show up. You have to be logged in into your ArcGIS account, and here in the top. So I'm just gonna call this Manaus store. I just have to put like a small summary. So Manaus stores for dashboard tags dashboard. Oh. Dashboard Brazil, and so I'm gonna put that is completely editable, so more people can add new stores if you want it. They're collecting information on the field, or maybe someone catch up that some information is wrong, so they can easily edit everything. I'm gonna hit this symbology compatibility sometimes depending on the version of your software or your app that you're accessing. This some symbology might get lost, so this might change a little bit of what we have here, or completely, depending on your type of symbology. And I'm gonna just create a new folder for this. Maybe I can just put it in my user, and I'm just gonna say that this is accessible to everyone. Let me just read this error. Okay, so for now I'm just gonna put it in my organization, because as it's not published there, I cannot make it public, so I will have to configure that later on ArcGIS Online. I'm just gonna analyze that everything is okay. Sometimes, depending on the information of your software and what you have there, some stuff can be wrong. So for instance, the projections of the maps are different. So I'm just gonna change my projection of everything to, let's see, which projection do I have here. Spatial reference. So I have everything in 4326. I'm just gonna change everything to be that one. Coordinate systems 4326. Okay, I have changed a little bit of the base map and rearrange everything. So I'm gonna reanalyze everything. I still have one issue with the service layer, and numeric IDs are not assigned. So for this one, I'm just gonna go to open my properties, and here in the general tab, you can allow assignments of unique IDs for sharing the web layers. And for this one, I'm just gonna update the map to use the base map coordinates. That's it. I'm gonna reanalyze just to check that everything got solved. Now that there are no errors, I can just share it, and it's gonna start creating it and uploading everything. And once it's done, we can open it directly on ArcGIS Online. So I'm gonna let it loading, and I'll show you later. So it has already finished uploading everything, and here I got a link to open my web map. So I'm just gonna click on it. It's gonna open it in my organization. You might need to log in on it, and here we have already the map. You can view it directly, you can open it back in ArcGIS desktop or whatever, and you can here create a web app. So I'm just gonna go to the dashboard, and yeah, it's gonna say like, oh, you're going to create a dashboard. What is the name? And like pre-configured, they will have already your map with your style and your layer, and you can choose different themes. This is for like a little bit of the coloring. So let's say I'm gonna do this forest one, and I'm gonna start adding some elements. So on the left side, let's say I'm gonna put a sidebar with a description. So Manaus stores. Let's say that this is a heading. And now a description. This is a map of Manaus stores designed for the EU Digital Twin course. Okay, I'm gonna save it. I'm gonna add here in between another element, and this time I'm gonna add some indicators. So I'm gonna start by saying that this is gonna be the layer that I'm going to use. And here you start seeing the type of indicators. You can get different statistics. So I'm gonna start with the count, and I'm gonna put in the indicator in the top text like number of stores. This is where you configure the values. So I'm just gonna change a little bit of the color. So I'm just gonna go with some of the green. Not too much. Yeah, let's say a little bit lighter. Okay, this is good. Now I'm gonna add another indicator, so I'm gonna just put it down here. Let's say pie chart. I'm gonna select the same layer, and I'm gonna organize them by shop, which is the category of the shops. Yeah, I have so many, so I'm just gonna go to my chart. I'm gonna hide the labels. So now it's better just to hover on it. And in the slices, you can turn on and turn off some of the slices. So I'm just gonna remove, let's say, I don't want to see the funerals, I don't want to see the gardens, I don't want to see hi-fi and interior decoration, whatever. And then you can also add a title. So this is stores by category, and in the bottom part you can put like it was last updated this many time ago, and this will be connected to, if you have live data, this will be the time that it gets updated, and you can also give the option to the user to download the data in a summarized way. So yeah, let's just leave it like that. And let's put another one. Could be, let's set it here in the top. No, it has to be in the bottom of here. And let's put a go. And you can add some filters, some conditioning. So I'm just gonna say that the shops are bakeries. Now I'm just gonna configure the titles. So bakeries in the area. You could also change the way that like is displayed. So I'm just gonna use this have done it. Gonna give okay. And the last thing that you can do, let's organize this a little bit. yeah, like that. You can go here to the map, and in the settings of the map you can connect it to the indicators that you just created. This way, when you move around the map, the indicators will get updated. So right now it's the full category, but if I zoom in, you see how it gets updated to the items that you're visualizing. And this is the way that your users would interact. So I'm just gonna finish, I'm gonna save it. And now that it's saved, I'm gonna go to all my dashboards, and I'm gonna open it. So this will be the kind of like the link that you could share to your stakeholders, so they could access the dashboard that you just created, and they could, for instance, expand each indicator accordingly to what they want to see. And again, the navigation feature that will update the information in all the 3 indicators. So now I'm going to show you how to do this on Python using Panel. So for Panel, they have this website, the panelhologis.org, and here you can read about how you set it up, and all the API and whatever it contents. So you can go here to the component gallery, and you can see all the panes and all the widgets and the configuration of the layout that you can have. And the idea of Panel is that you have kind of this grid setup. So I'm just gonna open it here. As you can see, they use this column and rows setup. And the idea is that you can configure it this the way you like. So you create, let's say here you can see, you create how many rows you want in this part, and how many rows, and depending on the spacers here, you get each of the items. So I'm going to show you how to start. So first I'm going to go to my VS Code. I already created a file that is the app.py. This is where I'm going to create my my dashboard, and I'm going to start by creating a new environment. So I'm just going to create a virtual environment. It's going to be Conda, and let's see if it works. Yeah, so I'm going to select 3.12. I don't know why 3.11 is there. And while it creates, I'm going to go to my Panel website, and in the tutorials there is this basic tutorial, and you can see here all the libraries that you might need. So I'm just gonna copy this this line, and I'm gonna install it in my environment. So let's wait for it to finish. And now that it has finished, I can go to my terminal. I'm gonna open a new one, and I'm gonna activate it. So conda activate. I'm just gonna copy the path from here. And once it's activated, you will see this parenthesis here, and I'm gonna paste my installation that I copied from the Panel website, and this is gonna take some time. So I'm just gonna let it run, and I'll show you in a bit. So it has finished already installing all the packages, and I'm gonna start by importing the packages that I'm going to need. So I'm gonna start importing Panel SPN. I'm gonna import GeoPandas, pandas. I'm gonna import the map widget.cesium as map widget, and I'm gonna paste one code that I had before. This is like the main item that it's gonna hold all your structure. So this comes from the templates. This is a material template, and at the end what I'm going to do is put like box that's servable, box. So just to make it work, I'm gonna write here one of the sidebar, and I'm just gonna put some markdown text. So I'm just gonna use these triple quotations, and I'm just gonna put a title. So Manaus stores, just to say that it's the same, and then some text like this was created for the VU digital twin course. And now in my sidebar, I'm gonna call that one, so I'm gonna call that site. And here in the terminal, I'm just gonna write panel. Oops, sorry. Panel. Let me clear my terminal. Sorry. So conda activate, copy path. And now panel serve and the name of my app, so app.py, and I'm gonna put this option that is developer, and this will create a localhost URL that you can open and see what you're working in. So let's just give it a minute for it to work here. So it created this localhost, so I'm just gonna open it in my browser, and you can see here that it's already kind of like configured. It seems like these the text on the sidebar didn't work that much, but you can see here how is the basic configuration. And I'm gonna start importing the map. So for that, I'm gonna go here and gonna do map Cesium equals map width.cesium, and I'm gonna call the latitude, if I'm not mistaken. Let's see this. Cesium map equals map widget.cesium. So you see that it put some default values. So I'm just change this to center. And I'm gonna put it was -60, and the other one was -4, -10, I think. I'm not completely sure. Center equals, and I'm gonna put the zoom, so zoom 10, and sorry, this is better with the altitude. Equals, I'm just gonna put like 600 meters, and I'm gonna put a token. So this token is the access code. So to get that access code, I'm gonna go here to my browser. I'm gonna go to my cesium.ion, and in this tab of access tokens, I'm just gonna click. I have one created here, so I'm just gonna copy this one, and I'm gonna paste it, and just to simplify the view, I'm gonna wrap it up. So yeah, this is my token. So I'm just gonna put it as a text, and and in the main one, I'm gonna call now the cesium map. So let's see if it works. So I'm just gonna save, and as I have this developing option, I don't have to rerun the process, so I just need to go back. So I have an issue here. The model map width decision doesn't have, oh yeah, because I call it as just map width, so I'm calling it double. time, so let's save it. And let's check what is the issue. So I have here, this is kind of like a guide, so I'm just gonna call this one, I miss the map. So that map altitude, and I can give also height of the window. So I'm just gonna give 600 pixels. Let's save it and go back here. I think I have to put that is pixels. So as you can see, this is kind of an iterative process, checking what works, what doesn't work. Let's see. So I don't have these model IP widgets, so I have to install it. So I'm just gonna do that, and I'll be back once it's finished. So now that it has finished, I need to call it as an extension of panel. So I'm just gonna create panel.extension, and I'm just gonna call IP widgets. And I created this line here, which is my main window. So in my main window, I'm gonna create this panel, which is gonna contain everything. And right now, I'm just calling that it to contain the map, the widget of the map. And I put this sizing mode, which allows to stretch it, and when you move it, so this would stretch the width. This is for adjusting to size to the size of the screen. So I'm just gonna save it, and as I have it running in my as a server, I can just come here, and now it's automatically refreshing. Let's see, maybe I have the wrong coordinates. Perhaps I put them, yeah, I put the wrong ones. So I'm just gonna change it. It's not -60 here, but it's minus. I just check, and it's -3, and this one is -60. So I'm just gonna save it. I'm going back to my map, and now I am in Manaus. Maybe I'm a little bit too far, but this is the details of the coordinates. And you can see here that is calling the standard buildings that are inside Cesium, but you can edit the in JavaScript, and you can to call your asset, and then you can use your own assets to be here. But now I'm going to show you how to do the indicators. So I'm going to start by creating a new folder, and in this folder I'm going to put all my data, all my assets, and in that folder I'm going to put my the stores that I had. So let me see where I store where I save my stores. So this was the PGT, the tutoring, dashboards. Oh, no, this is where I'm working right now. Let me see if it's here in something. Nope. Documents. Yeah, I remember now. In my ArcGIS, project, tutorial modeling, and I have here my shops. So I'm just gonna copy all the elements of the shapefile, sorry, and I'm just gonna paste it in my assets folder. And now I'm gonna call it to read it with GeoPandas. So let's call it stores equals GeoPandas that read file, and here I'm just gonna use assets that now stores not GeoJSON but shapefile. So these comments that you're seeing and this help that you're seeing for coding is from the Copilot. Now Copilot is free for everyone. and it will really ease up your programming. And now what I'm going to do with the stores is create an indicator. So I'm just gonna put like number stores equal panel dot indicator dot number, and here I'm just gonna use this that it has recommended me. And as I have to integrate it with these cesium panels, I want to show both of them. What I'm going to do is that I'm going to change a little bit here, so it's not going to be here the main one. So I'm just going to change this to CMAP just to have it easier. And then I'm going to call in the main one, I'm going to put one column. Yeah, so one column that has both of them. Maybe it's better a row. It will be as we design in the other one. And now I call it here my main one. I'm gonna save this and let's see how it looks in the panel. So it's updating. Is not finding my asset, so I think it's just a dot here. My mouse stores. Yeah, the mistake was in the name of the stores, because it's not my mouse stores, is shops and Manaus dot shapefile. Save it. So those are kind of the mistakes that AI could have. And yeah, let's see. So the indicator already loaded, but we have an issue with the map now. It might be the way that I'm calling it. CMap, it seems okay. Yeah, maybe it just needed some refresh. And as I put a width for the full row, it gets limited. But now you can see a little bit as it was in the previous one, and of course you can also edit the colors of the numbers of stores. So here I'm just gonna have style, and I'm gonna use color, and the color is going to be, I don't know, light green. I have to put this in quotations. Let's select this one. Let's save. Let's see if it works. Yeah. So let me check the configuration of the number. So how to edit the colors. So here, indicators. We have here the number, and oh, I just need to call it colors. So instead of style, I'm just gonna call it colors, light green. Let's see if now it works. Must be a list, and I call it as a string. So I'm just gonna put some brackets here, and I have to put a limit until which point that color goes. So for instance, if I had only 500 stores, let's put a parentheses. So 500 stores, this will be red, red. And now, oops. If I have up to 1,000, then the color will be light green. I'm gonna save it and let's see how it looks. It's refreshing. So now, because I am between 500 and 1000, then you can see this is the number. So that is kind of how you will create indicators in panel. It's a little bit more complicated than in ArcGIS. Of course, you have to do everything by hand. But I'm gonna show you one of the projects that I had. So this is a project that I've been working on. We just recently finished, and is a tool. Let me see. I haven't activated Conda here. Conda activate. Copy path. So now I can call panel serve my app and developer. Okay, so now it's open my browser, and here I have like a welcome screen, and I have a map here. Let me zoom out a little bit so you can see better. I have different indicators, different buttons to adjust indicators. So every time you push a button, this recalculates the indicators depending on what you have configured. So this is adjusting the population, for instance, and importing water. So this is a decision tool for a water supply issue, and this is kind of what you could achieve with building with panel. Okay, so that was pretty much what I want to share. The time was quite short to show you all the possibilities, so I tried to compress the 3 topics in a fast way, so you could get a overview of different possibilities. And I think that with this information you will be able to complete your digital twin and build your own tool for your work or for your thesis, or yeah, whatever it is that you're working on. So I'll see you in the question and answer session. Bye.